Today we are going to learn how to create a Sudoku solver in Swift. And as you can see here, we have the demo project, the starter project that we are going to use. Go ahead and check out the link in the description for the resources for this session. And of course, you will see this link right over here. I have already downloaded it, and yeah, there it is. It's just right over here. And yeah, we are going to solve some Sudoku. Now, before we get started, let me just remind you, basically, let's take a look at what Sudoku actually is and how it works, and therefore how we are going to create a Sudoku solver. So basically what we need here is we have this grid right over here, and you have to add the missing numbers, and there isn't any duplicates in a row or a column. And hello Sarabi, watching from the UK. Welcome from the UK. I got a hello from Hungary. Welcome. Yes, hopefully you will enjoy this coding session where we are going to learn how to create a Sudoku solver. So yeah, if we have 9, 1, 7 here, those cannot be added into these boxes nor into these boxes. And of course, we still have the rule of having the unique on these 3x3 boxes. For example, 9, 1, 3, 2, and 7 should not be in these 4 empty boxes. So basically that's it, and then you can just play around and solve it. Now, if you have ever solved this problem, we are not going to do it like a real human would do it. We are going to kind of brute force solve it, and yeah, it will be really fun. We are going to type quite a lot of code, and if you do like these Swift tutorials, or you just want to learn maybe Swift or Swift UI, I highly recommend you check out rebeloper.com/mentoring. It's a one-on-one 60-minute Zoom call with me where you can ask questions, or we can solve your bugs or problems, or you can just learn Swift UI with me. I can teach you the basics and of course, and also the advanced parts of Swift UI. I would really like to see you there. rebeloper.com/mentoring. Now let's get back into the Sudoku solver. And basically, if you download the starter project, you will see this Sudoku solver Swift app. It has a content view, basically that's what it is, and it has these 2 buttons to solve a Sudoku and find all the solutions for one Sudoku. So yeah, there might be multiple solutions for one grid layout. So we are going to code out the solve one and find all solutions. I have already added in there. So all we are going to need to do is just comment it out. I'm going to go through it, but yeah, it's kind of the next step after you understand how to solve it. Now we do have a content view model with all of these functions, and yeah, it just solve. Currently just printing out find all solutions and solve. Yeah, so we have Sudoku 1, and we are going to use Sudoku 2 for all of, like the second one, where we can find all the solutions for the present. There will be 20, by the way, because I have tested it. Yes. So as you can see, we have something called Sudoku right over here. We are going to build it out in the Sudoku solver, and this is just a simple struct that we already have in here, and some commented code out that we are going to tackle at the end of this video. Okay, so let's just start figuring out how we are going to build this out, because there will be a lot of code. First of all, we are going to add in these marks. So whenever you are going to add in, let's say 3 right over here, then that's called a mark. And the marks are basically numbers between 1 and 9. So we need to create some sort of a struct for that we can use later on. So, okay, so let's just create this struct right over here. And let's just name it, oh, well, not inside the Sudoku solver. Sorry about the cough. And let's just name this Sudoku mark. Okay, and this will have, and by the way, let's just make it public. Why not? public, because maybe you want to have it inside Swift Package Manager, which I talked about in a previous video of mine, which I really like. So yeah, we have our Sudoku mark, and what it has is a value. So let's have a public value, let value, and it will be an int value, because yeah, that's what we want to add from 1 to 9. Now, when we are initializing this Sudoku mark, we want to make sure that these int values are between 1 and 9. So let's create our public initializer here. So init, and let's just have an underscore value for that of type int. And first of all, I want to create an assertion. So we want to check if the value is between 1 and 9. Otherwise, we are just going to throw an error. It will basically not compile. So assert, and the condition basically will be if 1 is less than equal or that value, and that value is less than equal than 9. So basically, because we are between 1 and 9, we are going to assert with only values between 1 and 9 are allowed. Basically, that's it. Okay, so in this case, if we do have a value between 1 and 9, we are just going to switch through all of our values, and case 1 through 9, we are going to have self.value equals value. And because this is actually an int variable, we do need to have a default also in the switch statement. So default and self.value, and let's just set this to 1. Okay, I think that's okay. So the switch must be exhaustive error will go away, and it did actually. And that's our Sudoku mark. Now let's think of this like we are going to have these grids, and these grids will have the squares which will have the marks in there themselves. So let's create our Sudoku square first, and of course we're also going to move forward and create also the Sudoku, but just one step at a time. Let's take it one step at a time. So let's create a public struct again. So actually let's have a public enum, because we are going to have either an empty square or a marked square with the Sudoku mark. So enum Sudoku mark, Sudoku square, sorry, square there. There we go, Sudoku square. And we want this to be expressible by integer literal. So basically we want this to be able to be expressed by an int value. So expressible by integer literal. That's the one that we want here. And we have two cases. Oh, sorry, what did I do? Let's just move back. Expressible by integer literal. There we go. Okay, so we are going to have two cases. And the first case is empty. So this square could be empty. And the second case would be marked. And we are going to add in here a Sudoku mark. Now, these enums with these properties are really powerful. Next up, we want to create an initializer. So public init. And we are going to use the one with the integer literal. That's why we needed to have this expressible by integer literal. And as you can see, we have a value right over here. So let's just go through this value with the switch statement. Again, we are going to take a look at if this is the case of 1 between 9. So we want to have 1 and 9 right over there. Then self equals dot marked, and as you can see now it's auto completing, and then we have a Sudoku mark, open parentheses, and add in that value. So there we go, value, and the default value will be self equals dot, you guessed it, empty. So that's our initializers. This is how we create a Sudoku square. Now, there are quite a lot of things that we can do with this, but I would focus on two things. Is this an empty, so we get back a Boolean, or is this marked with a specific value? We are going to use these two properties later on the code, so let's just add them right over here, and it's pretty straightforward. We are going to create a variable is empty, there we go, of type bool, and we just switch through self, okay, and let's just use this one because it's automatically completing it. If this is empty, then we are going to return true, and we don't really care about the mark. All we care is this empty, so here we are going to return false. So that is empty. So next up, we want to know is marked with a specific value. So func, that is going to be a func, is marked with value, and underscore value. There we go. And that will be of type int, and it will return a Boolean. There we go. Again, we just go through the switch statement of self, and if this is empty, then we are going to return false because, of course, this is empty. It doesn't have any value. So return false. And if this is marked, we are going to return, let's just have here, return mark, that is Sudoku mark, dot value equals our value. So if this Sudoku mark equals our value, then we do have a value that is marked. Let's see, yes, it's two equal signs there. So we need to check if that equation works. And basically that's our Sudoku square. I know it's quite a lot of code right over here, but now we can create a Sudoku square that is empty. It's marked with a Sudoku mark. We can check if this is empty or is marked with a specific value. Now, next up, we want to create a Sudoku. Now, we are going to use a two-dimensional array, basically an array within an array, because we are going to take a look at the rows and also the columns. So we are going to create a public type alias of named Sudoku, and that will be this two-dimensional array of our Sudoku squares. So that's our Sudoku. It's really, really straightforward. Now, these are kind of the prerequisites for our Sudoku solver. Let's just recap. We have a Sudoku mark 1 through 9. We have a square that can be empty or marked with a mark. And then we have our Sudoku, a two-dimensional Sudoku square array. Now, how could we check if, so let me just go back over here to the previews. So right over here, we would just go like checking through 1 through 9, and let's see if that can be added to the Sudoku. So if we just check 1, of course, it should say, okay, we already have 1 right over here. That's not good. 2, we don't have 2. That's great. And then we move on to the next one. Again, 1, 2, and then 3. 3 will be okay. So we just move on to the next one. So this is how we will just go through all of those. But of course, we will not pick the correct number at when we are going through like 1, 2, 3, 4, like this in order. So we need to use recursion here. So let's say if we just go all the way up and then we don't have any possibilities to continue, then we just go back one more and bump up the value. So for example, we have 2 right over here, and right over here, let's say we don't have any possibilities. Then we just go to 3. And we don't have any possibilities, 4. So we just use recursion back to the previous value of the Sudoku. And you will see this inside the code. So here is the plan. First, we need to take a look at, is this value a good value for this row? Also, we need to know, is this value good for this column right over here? And finally, we need to know if this value right over here is good for this 3x3 box. So let's type out these 3 checks. Let's see, I'm going to make this private because after I make these 3 private functions, I'm going to bundle it all into one function so I can just check if that mark is a valid one. So private static, not struct, but static func. Okay, and let's just call this, does a Sudoku contain a mark at a row and a column? Okay, so well, actually, let's just start off with the row first. So does, and I'm just going to have underscore Sudoku of type Sudoku. Now contain mark, and that will be an int, of course, in column, or in row, sorry, in row, and that will also be an int value, and we are going to get back here a boolean. Okay, so how would we go about this? Let me just have more space. Well, actually, as I told you, we are going to use a for loop. So let's just go for, let's see, for the row. Oh, yes, let me just have in here our row, and then we would just go and contain mark. Let me just check here on my own for yes. Basically, we want to go through all the rows and the columns in these nested for loops. So for a row in, and that would be 0 and 2 dots, sorry, 0, 2 dots here, and 9. So from 1 till 9, and then for column in 0 till 1 till 9. And now we want to check this. So if, no, sorry, in, so if our Sudoku row and column is marked with that value, so that is actually our mark, well, contain mark, there we go, mark contains mark. So if it contains this mark, then we want to return true. And I think I know where I kind of got lost right over here. Basically, we don't need the row for this for each because we do have the row already. So let me just move this for column out and just paste it in there. Great. Now, otherwise, if we don't have any valid marks, then we just return false. Okay. So this will check if we do have any marks in that row that contain those marks. Okay, so next up, we want to do the same for the columns. Let's just do the same for the columns. We just need to copy that out in the column, and let's just name that OK. And then we just want to go through all of the rows from 0 till 9 and use that right over here, and then column comes from the function itself, function definition itself. Okay, so now we will know if that mark is contained in that Sudoku on the column or on the row. Now it's time to check out this 3x3 box. So in order to do this, we actually need to know where that top left, like top leading box is. And we're going to use a little bit of like box minimum row and box minimum column. So we are going to calculate that, and then we are going to go through with a nested for loop. Yeah, in this case, we are going to use that nested for loop. So let's just create another function. So private static func, and again, thus and Sudoku and contain. Oh, contain. Okay, not contains. Yeah, it's much more English. Contain mark of type int, and this time around we are going to add in a row and a column. So let's see, in 3 by 3 box with row. So the first one would be our row, that would be of type int. There we go. And then let's just have our column and of type int. There we go. And basically that's it. We are going to return a Boolean for this also. So how do we get that leading top left box? No, it's not a box. It is a square. Yes, so to the Sudoku square. Well, we want to create a box min at row. And this is really simple. So we want to get the row, divide it by 3, and then multiply it by 3. Multiply it by 3. Great. Okay. So that's not box min, that's mix box. Sorry. If I could type out correctly today, I'm a little bit not in the typing mood, but I do going to have a box max also, so max row, and that is we are going to use this box min row and just add 2 to it. Yeah, basically we are having 3 boxes, so yeah, that's our maximum row. Now we should do the same for the columns, so I would just copy this out and paste it in there. So column, and then the maximum column is this one. Okay, so now that we got this, we want to go through these box min and minimum and box maximum rows and box minimum columns and box maximum columns in this nested for loop. So let's just go and have a for, and that will be our row, and in box minimum row and all the way up to the box maximum row. Okay, and then for our column in box minimum column all the way up to the box maximum column. Okay, so what this does is basically we can just go through all of those 9 squares in that box. So now it's time to check if the Sudoku at the row and column is marked with the value of that value. So well, actually we called it mark, but I didn't add it right over here. So yes, we just go mark, and if it is, then we just return true. So we found our mark. Otherwise, after we went through all of these nested for loops, we are going to return false. Okay, so yeah, that's how we just check these 3x3 boxes. Okay, I know it's a little bit complicated, but go ahead, digest the code, and you will see that basically this works really fine. Now we have these 3 checks. We want to have kind of an all-in-one check, so let's just do that. Let's create another private static function and I'm going to call this is valid. So is valid, and the mark will be an int value, and then we do need to add the row. So at row of type int, and then also column, that's also an int. Okay, and in Sudoku, and that's a Sudoku of type Sudoku. Okay, and of course this will return a Boolean value, and basically I'm just going to see, now we are looking, is this a valid one? So that's why I'm going to use not does Sudoku contains oh, it's Sudoku right over here. So Sudoku contain mark in row and then row, and then we just go and not does, and just use the one with the columns. So Sudoku contain a mark in column, the column, and finally not, we need to have an end right over there, not does contain mark, Sudoku contain the mark, and that is our mark in the box with row, and we are going to add in our row and column right over there. So this will give us back if this is this a valid mark at that row and column. Okay, hopefully that error went away with that comma. And yes, so this is how we know that this is a valid one. Okay, next up, we want to find an empty square in the Sudoku. So when we are going to go through these empty squares, we want to know that, okay, this is the next empty square, and then this is the next empty square, and so forth. So for that, we are going to create another function. Again, private static func, and find empty square, find empty square. There we go. And in Sudoku, that will be a Sudoku. And this will actually return a tuple here. So that will be an int and an int. So it will give us back basically the row and the column. And this could be a nil, because if we don't have any empty squares, then it means that we have finished the solution, and that's why we will just return nil in that case. So again, this will be really simple. So we just go for row in 0 till 9, and then another for column in 0 till let's just have that typed out correctly. So we just go through all of the rows and columns, and if Sudoku at that row and column, and most probably you guessed it, we just have an is empty property there. So if this is empty, then we are going to return our tuple of row and column. Really nice. If all these two for loops, like the nested for loop, went and we didn't return anything, then we just want to return nil, because we didn't find any empty squares. So yeah, that's great. Now finally, this, and I promise this is the last helper function right over there. After that, we are going to create finally with these helper functions our solve function. So we need to store the candidate Sudoku at some point, because maybe that mark that we tried, it is okay, but it's not the right mark for the whole solution. So let's just have a candidate solution, so Sudoku private function like over here. So static func, and let me just call this candidate Sudoku, there we go, underscore Sudoku. I type out Sudoku so many times so that actually it just doesn't really make sense, you know, when you are typing out all of many words at the same word all over again. It doesn't really make sense for you. So the candidate Sudoku with the mark, so we want to know that mark that we kind of, this is our candidate Sudoku with this mark, and this let's just name this mark of type int. Okay, and of course we need to have the row of int and column int, and this will bring us back actually a Sudoku, which is a candidate one with this mark. Now, this will be a really tricky one because we want to actually insert this mark into the existing, not the, actually it will be also a candidate one, but a proposed Sudoku. So we want to create a result first, and that will be a new Sudoku. It's a variable, so we can just change it with our Sudoku that we have provided. Next up, we want to create a new row at that row that we provide. So new row equals array of Sudoku and row. So yeah, we got our new row. Then at that new rows column, so new row column equals dot marked, and we just add in our Sudoku mark with our value, and that's called mark. And then of course we want to add that row to the result, so result dot row equals our new row. Great. Of course we want to return that, so return our result. So this is how we would just have a candidate. Now we need the candidate again. We need that candidate because we want to use it as kind of a fail proof. If something goes wrong in the chain, we can just come back to this candidate Sudoku. Okay, so finally we can solve this. So this will be a public one. So public static function, and just solve our Sudoku. And yeah, we typed quite a lot right over here, but yeah, basically we just set the ground up for this really simple and straightforward function of solve. Okay, so first of all, we want to find the next empty square. So if it exists, so if let, and let me just have this tuple here, row and column. This is what we are going to get back from find empty square in the Sudoku that we provided. So if this exists, then we're going to do something. Otherwise, that means, so else, we are going to return our Sudoku because we have solved the Sudoku. There are no more empty squares to be found. Now, let's just go through the marks, like the proposed marks. So for mark in, and that's 1 between 1 and 9. So we just use 1, 2, 3, and 4. We just try this. Now, if this is valid, so if is valid mark, we just add in the mark right over there at row, and we just provide the row that we got from the find empty space and the column in the Sudoku. So if this is valid, then we want to create a candidate, because yeah, this might work or it might not work, but we are going to create a candidate Sudoku, and that is candidate Sudoku, yes, from our Sudoku with the mark of mark that we have just created, and at row, of course, and column. Okay, so okay, we have a candidate, but now comes the interesting part. If we can have, if we do have if let, so I'm just going to type this out and then you are going to understand. This is the recursion part. So if solution equals solve that Sudoku, then we are going to return our solution. Yeah, so basically this is it. So before we move on to the explanation right over here, if we cannot find any proper candidate for those 1 through 9 marks, and still we did find an empty square, we want to return nil right over here, because what that means is that the initial setup for our Sudoku is unsolvable, because we still got an empty square which we couldn't find a solution for. And basically this solve Sudoku is recursively calling this function, and it's just going to go through all of that. And yeah, it's not the Sudoku, sorry, we need to add in the candidate. Yeah, I just figure why. Yeah, we need to move that candidate into the next solve and into the next solve, and if it's going to come back, so if we don't have anything left, then it's just going to go through the next for loop with the mark of 1, 2, 3, and so forth. Hopefully that is kind of a good explanation, because you need to really wrap your head around it. Don't worry if you don't really understand it, just take a look at it in depth, and it should be self-explanatory after a while. Now these lines are kind of the most kind of tricky ones to understand. Okay, so yeah, basically that's it. Let's just add this into our let's see, what else do we have here? Yeah, the find all solutions. But before we find all the solutions, I'm just going to comment this function out. It's just printing out the solution, and it's really kind of fancy with the for loops and all of that stuff, but you will see that it's really straightforward to understand. Okay, so now it's time to go into the content view model and finally comment out the Sudoku 1, so we can just use it right over here when we are trying to solve that Sudoku, and it will just print out puzzle, and then we are going to go Sudoku Solver and then solve our Sudoku 1. Okay, now of course if let, well actually yeah, this needs to be inside an if let statement. So if we do have a valid solution, so if let solution equals that Sudoku solver solve Sudoku 1, then we are going to print out, and we are going to add this into a new line, and then solution, and we are going to actually print out our Sudoku. So Sudoku solver dot print Sudoku, and that's our solution. And let's just print out also, so Sudoku Sudoku solver dot print Sudoku, and just the initial values there. Now if we didn't find any solutions, so else, we just want to print out right over here no solution. Remember, if it's going to return nil, then that means that it's an invalid starter Sudoku. Okay, so now let's finally build and run and see this in action. I know there's been a lot of coding, but it's been really fun. Let's see this, and let's tap on solve, and let's see what we got here. Okay, there we go. So the puzzle is this one. Yeah, we have these lines for the empty ones, and then here is our solution. So yay, it is working. But this is not the only solution. This is the solution that it just found. So let's see how we can find all of the solutions. And for that, we need to go and uncomment this one. Okay. And I'm going to leave this for you as a homework to take a look at it and see how this looks like. And what I'm going to do in the content view model, I'm going to actually just invoke it. There we go. And then we have our puzzle right over here. So again, we are just going to print out the initial Sudoku. So Sudoku 2. And then we are going to initialize, like if, let's just type this out for you guys. So we are going to go Sudoku Solver dot find all solutions for our Sudoku 2. And we have this process and continue. Let's just take a look at what that does. We have a solution, and we're just going to print it out, all of that stuff. And then we're going to move on to the next one. And then, of course, it's just going to do the same thing all over again till we are going to run out of the solutions. So let's just go and create maybe a solution count so we can just print it out also. So solution count of type int equals 0. So let's just bump it up. Plus equals 1, and then print out. Actually, I'm going to just use this one. So print out solution nice water right over here. So Sudoku Solver dot print out our solution. There we go. And then we return true. If we don't have any solutions, and then we want to print out no solutions. And basically that's it. Now let's build and run and see if how many solutions do we find. So find all solutions. As you can see, it's just finding them. And we have actually 20 solutions right over here. And this is the initial puzzle. Then we have solution 1, solution 2. Go ahead and check them out. They all actually are a solution for the initial puzzle. And yeah, I know this is really a little bit tedious code. Go ahead and type it out for yourself. And if you do want to know how I would start to learn to code all over again from scratch and give you tips of how you can do that, go ahead and check out this video right over here.